Hello again, this is Mikhail with a supplementary session for the lecture 22, our programming session for one of our problems. Let me open that problem. So our example number 22.6 was asking to plot the graph of this PDF f of x and the CDF capital F. I will just do the graph of f in R, and let me recall that during our lecture we have obtained that k is equal to 3 over 4. So I will use that 3 over 4. So let's go to our studio. So this is my R studio. Now I want to define my PDF as a function. So defining functions in R is very easy. You are just giving a name. Say I'm giving a name f to my function, and this is the equality sign. In R you can use, if you want, just equality sign, but usually people are writing in this way in R. So I'm writing function to say that this is a function of a variable, say x, and here will go the body of my function. So the function is defined in the following way. It is equal to 3 over 4 times x squared plus 1 if x is between 0 and 1 and 0 otherwise. So I need to write if x is larger than 0 and x is less than 1, then please return 3 over 4, this is 0.75 times x squared plus 1. And otherwise, else, please do the following: return 0. So let me run. So I'm selecting the function body and hitting Control Enter. Now let us check that this is calculating, working correctly. By the way, we have a function, new function f in our environment. So let me calculate what is the value of f at -2. I'm running that, hitting Control Enter when standing at this line, and it is giving 0 here. Say I'm choosing f at -1, again 0. If I will choose f at 3, that will give 0, but if I will try f at 0.3, it will be not 0, it will be 0.8175. Okay, so one important thing is that this function will not work on vectors. So what I mean, say sine is a function and I can calculate the value of sine at 3 and it is giving 0.14. Okay, if I will put here a vector, say I'm concatenating two numbers, say 3 and 2, and I'm running that. So sine is calculated at 3 first, then at 2. So if I am running this function on a vector, it is returning a vector of corresponding values of that function. Okay, so let me try to run my function f at this vector. So I'm running and it is giving just one number. But there is a function vectorize in R that makes functions to work with vectors. So I will use that vectorize function. So let me define g to be the vectorize version of f. So I'm running this, and now I can calculate, say, g at sorry, let me keep this, g at say 0.4, g at 0.4 is 0.87. If I will calculate g at 0.3 and 2, I will calculate g on a vector that is returning a vector. The value of g at 0.3 and the value of g at 2. Okay. Now having this function, we can draw the graph of that. So I am making a partition of dense points in some interval. So sequence of points, say starting from -1, I will draw my graph from -1 to say 3. Sequence from -1 to 3 by 0.01. Well, I'm running this and it is giving a sequence of numbers starting from -1 and with a step size 0.01. Okay, we can write even, we can add the names. So from -1, sorry, to 3 by this. This will give the same result, of course. Now I'm calculating the value of g at t at this vector, and this is giving another vector of the same size. For zeros, and then I will have some non-zero elements, and then again zeros. Now I can plot the graph of this function g of a or f just by plotting pairs t and y. T and y. If I will run this, I'm running that, I will have this kind of graph because R is putting a little circle at every point ti, yi. So I can change that by writing type, the graph type to be lines L. If I will hit that, if I run that, I will have this kind of picture. Let me just make line width to be say 2 and color to be blue. So this is the graph of our function f, the PDF of our random variable. By the way, R is joining these points, and for real graph we will not have this kind of vertical lines. Okay, this much. Thank you. Bye.